This is the exact same section of 14.4. It just becomes, you solve your problem, you solve your problem. You do all of the exact same work as you did before. The only thing that's going to wind up being different is how you write your answer, how you write your result. So what we do here, when we're talking about what's called general solution.
Do you need a calculator?
No, you don't. You're not going to use calculator for this stuff. This is still 14.4. So what will happen here, instead of being within one revolution, we're going to find the solution and then list it out in terms of how long does it take me to get back to that same solution.
Is this all everything we're learning today, general solution?
Yeah.
So you can tie that in.
Yeah. So for example, if I want to do a general solution of 2 cosine of x plus 4 equals 5. Yeah. If I want to do the general solution of 2 times the cosine of x plus 4 equals 5, we do the exact same thing as we did Wednesday and earlier today. So what do I do first?
Subtract 4.
Then,
Divide by 2.
so we're left with the cosine value. What angle has a cosine value of a half? So we write it as x equals the inverse cosine of 1/2. So we place it in our triangle, knowing that it's going to be our adjacent over the hypotenuse. So it's a 60-degree angle, so it's pi over 3. Very easy, quick, painless, not a big deal. What general solutions asks us to do is what other angle, in this case, also has a positive cosine value of pi over 2, or excuse me, 1/2. What quadrant would that be in? Where else is cosine positive?
1 and 2.
Fourth, because it's your x values.
I think it was cosine, okay, so cosine x, sine is y.
Yep.
So,
So the 3/3, well, no, it's 11:24. You got the wrong time zone. So this would be in terms of our full circle radian, terminal side here, because we go all the way around to this. It's going to be at 5, what is that? So it'll be 5 pi over 3? Okay.
Over, yeah, 3.
or isn't it?
In these cases, we're spinning it, we're not bounding ourselves between the first, second quadrant like we did before, because we find these full-on solutions. So the difference between yesterday of just listing out the angles within one revolution is the generality of it. Because what I'm going to look at is there a common difference or a common amount of pi that I have to add to get from here to here, and then from here to here? Are those equidistant from one another? No. So, but what I want you to think then is, how long does it take me to start at pi over 3 to get back to pi over 3?
2 pi.
2 pi. So every 2 pi revolution, I'm going to be there, won't I?
Yeah.
Or will I be square? Not 2 pi over n, I'm sorry, 2 pi n. So every time I go around the circle, I'm going to be back at pi over 3. I'm going to be back at a cosine value that's equal to 1/2, no matter what. So every time I spin around,
So that would be your answer, right?
yep, and I do the same thing for the 5 pi over 3. I think about the same idea. How long does it take me to get from here to here? 2 pi again.
Why did someone come up with this? It just seems like common sense.
It does seem like common sense, but what this means, this is an extremely general solution. All it says is that every time you're at pi over 3 and you add 2 pi to it, you're always going to be back at the same spot.
What is the end statement?
Number of times you go around.
So, but it's always going to be.
It's not always plus 2 pi n. Sometimes it can be plus pi.
What if n was 1?
Oh, no. The n means full revolution. Okay? Yes, sir.
So is that our final answer?
Yep, that's as general as it gets. Then it's your basic commonality. So when you don't see a boundary to look for, like between 0 and 2 pi, it is implied that it's looking for what's called the general solution. And your general solution is an unbounded answer. Means there are going to be infinite answers to this. No matter how many times you go around the circle, every time you stop at pi over 3, you're still going to have the same value of cosine, no matter what. Does that make sense? That's really all it is. The trickiness is just being able to figure out the tack-on values, depending upon the problem. Each one of them is a little bit different. Same idea here. Let's look at 3 secant squared of x minus 4 is 0. I'm going to find the general solution again. Everybody okay with adding 4 divided by 3?
Yes.
Okay, let's start with that. And then take the square root. Good. So we have the secant squared.
We don't need to grad.
No, sir, not at all. So you have the secant value. I'm just going to say x is going to equal the inverse secant of 2 over, oh, thank you, plus or minus root 3. And you're right. You do not need to rationalize these because you're just using that value to place in your circle. Yes, sir.
So would you recommend that if they give us like an inverse trig function, like secant, cosecant, cotangent, should we just keep with it, or?
If it's by itself, go for it. But if it's tacked in there with a cosine, simplify.
Alright.
You know what I mean?
Yeah.
You'll start to play with it a little bit more as it gets more complicated in 14.3. Okay. Now this one here, we place it in our circle. We know that we have a hypotenuse of 2 and an adjacent of root 3. So that gets me at a 30. Very good. So I'm at pi over 6. The other, and then since it's plus minus, isn't it going to be a pi over 6 reference angle in each of the 4 quadrants?
Yeah.
So here's what we do. We list it out. We have pi over 6, 5 pi over 6. I'm just going to go around 7 pi over
Well, it's
6.
going to be plus or minus.
I'm just going to move these. Oops.
11.
And then the last one was,
11.
all right, right here. So I'm just going to place this real quick. Jeez Louise. Let's shut it off, please. Are all 4 of those points the same amount of distance of pi away from each one another? No.
No, the top 2 are the same distance as the bottom 2 are. Same size, but not each one is the same.
Correct. Each individual of those 4 points are not equidistant to one another. It creates a rectangle. So you've got the top 2 are the same distance, the vertical 2 are the same, and the bottom 2 are the same. So you get those values. But one thing that does occur is this. Isn't this spot and this spot pi away from one another?
Yes.
And then the same thing here, that this one to this one, those 2 are pi away from one another.
Yeah.
So the most basic general form of writing the solution is to take the first positive, pi over 6, add pi n, because that gets me here. If I add pi n to that, it gets me back here.
So we're not.
Oh, so you have to get his base.
Correct.
So that's going to be the most basic of the basic, or will you ever be able to add like pi over 2?
You will when you're at 45. So I'll show you an example of that here in a minute. And then,
Okay, so you're just going like, okay, from this point, how long in terms of pi does it take to get to the next point?
yes, and if
Is
it's not the same, obviously it's not the same to get from here to here as it is from here to here.
it- So you can't tell what the distance is?
Correct. But here, you know that you're pi apart. That's why. So then I don't have to write anything about the 7 pi over 6 because that was the plus pi to this. So this one was the other add a pi to get to here. And all I have then are 2 solutions listed, but it's going to get me from my positive solutions
Yeah.
to my negative solutions.
Because pi over 6 plus pi is.
So it's just going to get me all possible solutions here. Yes, ma'am.
So I'm so confused, like, on the last one you used like 2 pi over n, or 2 pi n, and then this one you just use pi n. That's what I'm like.
What happens here, if you look at it in terms of just placement, the distance on the curve from here to here is not the same as the distance on the curve from here to here. So I can't say that these 2 are not the same amount of the arc. But if I go from here to here, and I go from here to there, those two arcs are the same value. They're both pi. It's halfway. It creates half circles. So the most general form, instead of writing out all 4 angles plus 2 pi n, is that I can write this angle plus pi n gets me here, plus pi n gets me back here, plus pi n gets me here, and I just wind up oscillating between the two quadrants. Same thing here, and back, and back, and back. It's just it's the most simplistic way of writing it out. How long does it take me to get to the next one, and is that distance the same each time? That's all that is. Whereas the other one, we had the quadrants where we had the point here and here. So as you went through from here to there and back, those two were not the same value. They weren't equidistant at all. So you wind up having to start, well, I start here, takes me 2 pi to get back. If I start here, it takes me 2 pi to get back. That's why the difference between plus a pi n versus 2 pi n, or in a minute we'll look at a pi over 2 value. Okay? It's very subtle, and it just takes a second or two to figure that out. All right, yes, ma'am.
But couldn't you just, figure out the distance between them? Because with the 30-degree ones you're talking about, like, you can pretty easily figure out that it's 4 pi over 6 from this one to the one in the second quadrant, so why don't you just say that?
Because is it 4 pi over 6 to get to the next one? That's fine. You're looking for it, it has
to apply to all of them.
Correct.
Okay.
You want to write it in terms of it being as simplistic for however many of them you can get to. Okay. The one that you wind up with, which one gets me there? Oh, which one does it? Okay, let's do this. Oh wait, no, I don't want tangent. I'm sorry. I need this to be sine.
Too bad.
You'll get over it. Everybody agreed? Add 1, divide by 2.
Yeah.
No.
Take the square root.
Yes.
So is everybody okay that this winds up at pi over 4?
Yeah.
So here's what happens when you're at your pi over 4s. So we have our opposite and our hypotenuse. So this sine value is pi over 4, which means that it's also here, here, and there. Now what I want you to think about is at pi over 4, aren't the ordered pairs always the same? Root 2 over 2?
Yeah.
For cosine and for sine? So if you have something placed in a quadrant and all the ordered pairs are the same, but their signs, S-I-G-N, alternate, what do we know about all their sides? They're equal. They're all equidistant. They form a square, and the reason they're pi over 4 is because you get right angles, because remember they're horizontal and vertical.
Because it's 1 and 1.
Right. You get you get a right square, you get a square at these 4 values. So what happens here is to get from pi over 4 to 3 pi over 4, to 5 pi over 4 to 7 pi over 4 back to pi over 4, all you're doing is adding pi over 2 each time. So the only time you have to worry about the pi over 2 when you're tacking that on is if you have a plus minus for a 1 in root 2. If you're plus minus at a 45-degree angle, your answer is always going to be pi over 4 plus pi over 2 n.
That's it?
That's it.
Okay.
That's really the only time that that occurs to be pi over 2, because it's the only time within our circle, our unit circle, that a square occurs. At pi over 6 and at pi over 3, they're both rectangles. And pi over 4 creates the square. That's why you get the pi over 2's, because pi over 2 is 90 degrees. So this means start at pi over 4, go this way, make a right 90 degree, make a 90 degree, make a 90 degree. That's all that is. Yes, sir.
So at pi over 3, it would just be plus 2 pi n.
Yeah, well, unless it's all 4 quadrants, then you can do pi over 3 plus pi n to get to the 3rd quadrant, and then use your 2nd quadrant plus pi n to get to the 4th.
Because if you did plus 2 pi, then you would have 4.
Correct, and you're overlapping. Then you wind up just overlapping. Does that make sense?
Yeah.
Yeah, this is the only, it could be sine or cosine to get the 1 over root 2. Remember that. That's okay. And that'll happen. All right? Not visibly super scary.
Are you going
Yes,
to make it scary?
Well, we have to do a little bit more of the factoring and stuff like that.
Factoring.
Today?
No, we'll do some of that, more of that factoring junk when we get into more of the what do you call it?
That's what the part would be.
The 14-3. Let's see, we'll do one more.
Quick question, are they gonna like get back to us and say like how good or bad we did?
I don't know, maybe.
I don't think anything.
Once they see like the results, they're gonna be like, wow, no one cares about this.
I did.
I knew how to do
And then I
back
really,
with the
really.
bell.
Did you have to write a poll?
No.
No.
Oh,
On the first day when I was being silly, I
I
had to
looked,
go to meet.
it was funny because I was looking and
Give me a general solution to that, please.
the girl, I have a funny story in a second.
It's probably not a funny story.
Jeez, you don't. I mean, you can easily make mistakes. Divide by change the square.
It's not possible.
It is.
So yeah, so the root of sine x equals 1.
So what angle has a cosine of 1?
What angle?
Think about your quadrantals. Ordered pairs. 1, 0. Negative 1, 0. 0, negative 1. And 0, positive 1. Which one of those has cosine equal to 1? At 0. So the cosine here is 0. In terms of general solution, it'd be 0 plus 2 pi n.
Wait, so why is it 0 again?
Because that's the order pair. That's at 0. It starts at 0,
Yeah.
2 pi, 4 pi, 6 pi, 8 pi, 10 pi.
Because you know what in pair.
You have 20.
So
Okay,
cosine
is the answer
X is
zero,
1.
like, for the other ones, is it pi over,
Alright, yeah.
pi over 4 plus pi over 2,
Wait,
or is it like pi over 4,
Well,
pi over
technically
6,
X
or
over
5 pi over
R
6?
plus, it's in the X slot.
For the last problem?
No,
And then
for
sine is
all the
y.
problems, like,
And
what
then
is
it's
the
like you
answer?
use sine over.
It's the angles that you find, and you're just trying to, instead of having, if you have 2 angles, are they equidistant from one another? If they are, you just have to list it out 1, and then you tack on the pi n or whatever.
So like, do you write like the little equation, or do you write like the pi over 6, 5 pi over 6, 7 pi over 6?
It depends. In this case, the only value that it gave me an answer was at 0. And every time I get back to 0 is when I add 2 pi to it. So that's why my answer is 0 plus 2 pi n. Whereas the ones we had earlier where you had where we were first and 4th quadrant with the 60, where this one was, so this was pi over 3. And this would have been 6 over 3, so it'd be 5 pi over 3 at those 2 angles. This one, adding to get to here isn't the same as adding back to here. So my answers were plus 2 pi n for both of them.
So you don't list out the things you went there.
Correct, because you only had 2 angles, because it just was here. If this case was a plus minus, if it was a plus minus, then this angle is repeated at pi, and then this angle was repeated at pi, so you wouldn't have 5 pi over 3, you usually go to the second quadrant one and do that. That's all it is. Okay. Does that make a little bit more sense? You're trying to write it in simplistic terms as possible in terms of revolution. Okay. Let me give you some of these to try out. Go ahead and tack on to what you guys did last week. It's just the page before what you guys were working on yesterday. I don't know, what page is that?
Well, the problem is you gave us
859.
we're on 860. Yeah, you gave us 861. But
Yeah.
Sorry,
It's okay.
sue me.
Can we?
No.
I didn't think they could anyway, just because I don't think we have logical enough laws.
Do those, please.
Yeah,
Sue me, no.
There's a lot of lawyers that they want to get business, so they do if they like.
It's called pro bono work.
If they don't win your case, then you don't have to pay.
You watch a lot of daytime TV.
Yeah, exactly, because they'll be like, I haven't lost a case for
All right, well-
5 years. They don't have lawyers.
Unless your name is Saul, then you don't go to trial.
What's the guy's name?
With the